This video is on graphing radical functions. I'm going to be graphing cube root functions. I'm going to be doing 2 of these. Since we're dealing with cube root functions instead of square roots, we no longer have a start point, but we still have a key point. The key point here is still our h and k, but instead of it being the start point, the cube roots will actually go left and right forever and also up and down forever. So our domain and range will be infinities. That means that we have a key point because our key point is actually going to be basically the middle of our graph. So our key point is still our h and k. Our h still comes from the inside what will make this 0. So we would have 2 minus 2 would give us 0. So our h value is 2, comma. The k value is what is added or subtracted to the outside, which is nothing. So that's 0. So since it's a key point, we don't start it with 2, 0. We actually want to put 2, 0 in the middle, almost as if it was our vertex. So 2, 0 would go in the middle. We do want to find other coordinates to use. So when we go to our y equals, we want to do cube root. So if we go to our math button, we want the cube root, which was down here on number 4. So the cube root of x minus 2, all of x minus 2 is in there. And then we want to make sure we get out of the radical. So I want to press graph. And as you can see, the graph is going left forever, and it's also going right forever, and it's also going down and up. So it's not that's why it's not a start point, it's a key point. But if we look at the coordinate 2, 0, which is about right here, this is where the graph is changing its curve, basically. So it's going up to 2, 0, but then it's going back out to the side. So this would be more of the middle of the graph. So if we go to our table, we want to get more coordinates. So we want 2, 0 to actually be in the middle of our table. So I'm going to actually scroll up some more to get so that 2, 0 is actually in the middle. So I want a couple more coordinates that are above my 2, 0. So as you can see, the 1, negative 1 is above the 2, 0. So I can do 1, negative 1 here. And then I want to scroll up to see if I can find another one. So I have a negative 6, negative 2. I can graph it above. So negative 6 and then negative 2. Now I want to go get 2 more. I want to try and get as many coordinates as I can. So I'm going to go back to 2, 0. So that's in the middle of my graph. Then underneath that would be 3, 1. These are not mirror images of each other, but they are close in number, but just not the same signs, it looks like. So the next one would be 10, 2, which I won't be able to graph this one, but I will know basically where it's going to end up. So if I graph this, I'll actually start at 2, 0 because that's my key point. So 2, 0. And then I'll do 1, negative 1. And then I'll also have 3, 1. So this almost looks like a line here. It's not linear. This is actually curving, so we do want to make sure it curves. We also have that negative 6, negative 2. And then our 10, positive 2 would be somewhere more over here. So I can kind of put a little dot there saying I know that this is roughly where it's going to go. Not exactly, but close. So what we want to do here is there will be arrows on both sides. When we connect these, we want it to curve. It's not a line, so it's not going to be angular. It's going to actually curve. So I'm going to make this curve a little bit, almost like an S. And then I'm going to go towards my other coordinate. Now I do want to put arrows on the ends of both sides. So with this in mind, our domain, because it's going left and right forever, that'll be the infinity. So both negative infinity and positive infinity. For the range, this graph is going to go down forever, and it's also going to go up forever. So down is negative infinity, up is positive infinity. So the range is actually both negative infinity and positive infinity again. Now to talk about our transformations, we still are focusing on our parent function. This time, our parent function is the cube root of x. So we still deal with the function notation of our a, h, and k. So our a is equal to a positive. Our a is equal to a 1. Our h is equal to a positive 2. And our k is equal to a 0. So the parent function is positive, positive, so we don't have to do anything there. 1, 1, don't do anything there. 0, 2, so this we have to talk about. and then 0, 0. We don't have to talk about that one. So it's just the h value. So again, to get from 0, 0 to 2, 0, we just went right 2. And that's our transformation. On example 8, because this is, again, a cubed root, we have a key point, not a start point. We still want our h and our k, so our h value still comes from inside the radical. The h value is what will make this 0. Negative 3 plus 3 gives us 0, so our h value is negative 3, comma. The k value is what is added or subtracted to the outside. So over here, this is 1/2 is multiplied to it, so it's not that. But this 1 is a positive 1, which could actually be rewritten. If we rewrote this, we could have y equals, so we know what our function notation is. This negative 1/2 is multiplied, so that's our a. Negative 1/2 cubed root of x plus 3. And then we have this positive 1 right here, which is actually on the outside over here. So our k value is actually that positive 1. So again, since it's a key point, we want to put that in the middle like our vertex. So negative 3, 1. So when we go to our calculator, we want to go and clear this out and type in this original one. So it's 1 minus, parentheses, 1 over 2, 1/2, close parentheses. Then I need my cube root. So I need the math button. Go down to number 4. And I want to type in x plus 3. Get out of my radical. Now I'm going to press graph. So we've said the key point should be negative 3, 1. And we can see that that little middle part is roughly about that negative 3, 1. And we can see that this is very thin almost. And if you look at that 1/2, it's kind of making it closer to the x-axis. So if we go to our table, we want to go to negative 3, 1 in the middle. So negative 3, 1 is a coordinate, and we want that more in the middle. So here's negative 3, 1. We want to try and get coordinates, at least try and get 2 above and 2 below. So we have negative 4, 1.5 is a good one. Let's see if there's another one above that. These aren't really good coordinates. So we have negative 11, 2. Now we want to go back down. So I'm going to get negative 3, 1 again. Make sure I have that one. So then underneath that is negative 2 and then 1/2. Let's see if there's another good one underneath. So we have 5, 0. So we can graph this one. This is the only coordinate that will be a little hard to graph because we don't have the, we only go to negative 7. So for our coordinates, I'm going to start with the negative 3, 1, which is our key point. Negative 3, 1. Then I'm going to go to negative 2 and then 1/2. So here's negative 2 and then here's 1/2. Then I'll also do the negative 4 and then that 1.5. So negative 4 and then 1.5. So again, this kind of looks linear. Remember, it will curve. It's almost like an S shape. Then the next one is 5, 0. I can graph this one, 5, 0. And then the other one was that negative 11, 2, which is way over here, which I won't be able to graph, but I will keep extending my graph as much as I can. So I do want to connect these. Again, here is more of it's an S shape, so it will curve. This is where it starts changing its curve. So it's going to curve this way, and then it will curve back, almost kind of up. So it's almost like an S shape. And then it will extend to get that 5. We'll keep going. Then this will curve to go this way. And there will be arrows. So domain, this graph is going left forever and right forever. So that's negative infinity and also positive infinity. Negative infinity and also positive infinity. This graph is going right and down. This is going slowly down, but it will go down. And this part of the graph is actually going to keep going up. So it's also going to go to negative infinity and then positive infinity. So for our transformations, we're going back to what our parent function is. So since it was a cube root, parent function is the cube root of x. Our a value is a negative, because if we look back at this orange, rewriting it into the correct format would help us. Our a value is negative. Our a value is also a 1/2. Our h value is a -3, and our k value is equal to a +1. So for the transformations, positive to negative, we have to talk about that one. From a 1 to a 1/2, we have to talk about. From a 0 to a -3, from a 0 to a 1. So we actually have all 4 transformations happening. So the negative tells us it's reflecting over the x-axis. So reflect over x-axis. The 1/2 tells us that it is being a vertical compress of 1/2. And if you see it from this example up here, where it's actually more spread out, where you can see more of it, this one is actually pushed more together, which is why it's being compressed. We also have to talk about our coordinate of -3, 1. So again, from 0, 0 to -3, 1, how would we get there? We would go left 3 and up 1, and that is what the transformation is. Left 3 and then up 1. So again, because it's a cube root, we have a key point, which is why we put it more like the vertex, because it's where the middle of the graph is, where it kind of changes its curvature. So that's why instead of a start point, we've called it a key point.